Hey, hello, and welcome to the show. It's me, John Park, and you are here just in time for JP's product pick of the week. It's the weekly show where I find a cool thing from the Adafruit product line and show it off to you. Sometimes it's a new thing, sometimes it's an existing thing, a favorite oldie from the archives. But I think what you're probably going to want to do is head over to the product page, which is right here. Ignore the caw-caw. That was from last week. I forgot to change that. But this URL and the, what do we call this, QR code, that'll take you right to the product page. Inside the product page, you will find this video happening, as well as a big, gigantic, huge discount available on the product pick. And you can get up to 10 of them if it's something you really love and want. Just make sure that you check out pretty soon after the show ends, because there's no coupon code or anything like that. It is just simply discounted during this show. After the show, the price goes back up. The product is still cool, it's just more expensive. So you know how that goes. So let's see. What I want to do first off with this product pick is have Lady Ada introduce it to us. So please take it away, Lady Ada.
We have a new Stemma QT board. This is an arcade, LED arcade Stemma QT Breakout, which lets you connect up to 4 arcade buttons with LEDs built in. And here, thank you, is a wonderful video of Jelly showing off our 23 millimeter arcade buttons. And they have LEDs in them. And we had some people who were doing projects and they're like, I want to make MIDI fighters, or I want to make an arcade interface. But before you know it, you're using a lot of PWMs, you have a lot of inputs. Could you make a version that makes it easy to control these? And in addition, our red and yellow LED arcades and other LED arcade buttons often need 5 volts for the LED. They're not designed for 3 volt logic and power. And so there's a little mini boost converter on there that'll convert whatever voltage that's coming in to 5 volts. So even if you're running this off of a Raspberry Pi or an RP2040 that's a 3.3 volt logic and power board, the LED will be lit and PWM'd with 5 volts. So it's I2C to 4 button inputs and 4 PWM LED outputs with 5 volts max current drive. There is a resistor in series, so if the LED doesn't have a resistor, don't worry, you're not going to blow out your LEDs. It's like super safe no matter what.
Okay, and you want to show it off?
Yeah, I thought I'd show it off. So this is the same, I think it's 1 inch by 3 inches that our other, the Neo key and the Neo slider. So it's kind of a, DIY interface using all the same size PCBs. Here I have it plug and played into a Stemma QT port on a QT Pi. And there's a little microcontroller with 4 address jumpers, and this is connected over I2C. And it's reading the button press, and you can see it's pulsing the LED PWM and 8-bit PWM number from 0 to 255, and you can see how responsive it is. Like, even though this is over I2C, the button is red and the LED is written is happening pretty much instantaneously.
Do we sell those wires?
Yes, these are arcade quick connects. They're great for connecting to arcade buttons and micro switches very easily. No soldering is required, which is why I particularly like this for if you want to add arcade buttons. You just plug the JST XH connector in, and it's polarized. And then on the other side, these, they're a tight fit on purpose. I kind of don't want to break this.
Yeah. Okay.
Okay, I don't want to break it, but
Yeah.
if you use pliers, they pop
Yeah.
right off. But if you're using your hand, I don't want to. You're not supposed to
Don't.
yank by the cable.
We're-
Don't do what I just did.
The demo gods are treating us nice tonight. Let's
Yeah.
not tempt it.
So yeah, you don't have to use these small LED buttons. We also have ginormous ones, but you'll just want to make sure you have the right arcade quick connects for whatever size button you've got and LED socket. We have a new Stemma QT board. This is an arcade LED arcade Stemma QT Breakout, which.
Whoops, I didn't set that to hold, so it's going to loop on and on forever. But yes, that is the board. It's let me go ahead and grab mine. In fact, I'm going to jump down to this overhead, and we have we got a fancy velvet mystery box this week. So let me go ahead and open that right up. This week's product pick of the week. Ooh, it is the LED 1x4 arcade button board. That's right. The LED arcade button 1x4 board in Stemma QT format. This is, let me switch cameras again. This is terrific. This is, again, part of our line, as Lady Ada mentioned, of boards that you can use to build an interface. So we have sliders, we have Neo keys for mechanical key switches, and now we have these arcade buttons. So imagine, if you will, hooking up arcade buttons before the era of this. It was a lot of wiring. You have 4 wires per button with these lighted buttons because you've got the switch and you've got the LED. And keeping track of those can be a bit of a daunting task. This drives the LEDs with PWM, this reads the switches, and it handles it all with that little Stemma QT connectable Seesaw chip. So the Seesaw chip takes care of all the digital I/O on this board, all the PWM on this board, and then it just is receiving and sending messages back and forth to your microcontroller over Stemma QT. So let's take a look, in fact, at a little bit of a demo. Let me switch back down to this camera here. And I'm going to take a couple of arcade buttons here, and you can see I've got these little quick connects. And I like to mark mine so I don't put them in the wrong slot here. Now these are polarized, so you won't get ground and power messed up on the LEDs, which is good. But the bottom one here is LED. And the top one is for the switch. And that's all it takes to connect up one board right there. I'll go ahead and connect up a second one just for fun. You can do up to 4 on each board, and then you can daisy chain a bunch of these boards together and get lots and lots of LEDs. I'll show you an example of that in a second. So one of the things I love about this is that it is a no solder system. So you can plug in arcade buttons without doing any soldering at all. If you're using something like this little microcontroller here, this is a QT Py RP2040. It has the Stemma QT connector built onto it, so we can just plug into the board. And again, your connections are made with 0 soldering. So I'll go ahead and put power to this. This is running CircuitPython, and I just have a simple bit of code on here that will just light up a button when I press it. And the code for this, we have PWM code as well. Actually, I'm not using any PWM fading in this example, like you saw in Lady Ada's example. I'm just lighting them up or not. The ability to add multiple boards is terrific. Also, the ability to use some of our other bigger switches. So in sort of part 2 of the demo, I have this here. This is a little button box. Let me move my camera a bit here. Get a bigger view of the world. This is a button box I had built for a project with some funky different button types. And inside there, I've connected them up to another of these arcade button boards, and then I just have my little Stemma QT cable running there. So what I'll do is plug that in to this board, and I'm actually going to go into the code and enable the second board. So these are on I2C, so you need to tell it you're using multiple I2C. So if we jump over to this Atom view here, I'm just going to uncomment 2 lines here, and now it's going to look for a second I2C device, which means we will have the second board available. So now you can see when I press any of these buttons here, we get them to light up. And the first set, those are still working as well. These, by the way, allow us to quick connect as well. Even though they have some different sizes of cable, we have 3 sizes of cable connectors for the terminal lugs available. So no matter which of these lighted switches you get in the Adafruit store, you'll find we have connectors that'll terminate in that JST 2-pin there at the bottom of the board. Now, I mentioned that we've got a ability to put together a project that has a whole lot of these in it. And in fact, this one I built, you may recognize my arcade MIDI controller and synthesizer, this one has a set of 4 of the boards inside of there because we're using 16 buttons, and then I'm doing joysticks separately. So that's a real mess of wiring if you're trying to keep track of that and drive that. Just the sheer number of PWM pins that you would need gets to be pretty high. So it's a real benefit to be able to use this board, which drives the LEDs on PWM, and it does all the digital I/O. So let's take a look at just a little bit of the code here. And on the way to that, actually, I'll answer a question from the chat. Todd asked, what's the biggest button Adafruit sells? I forgot to, did I grab one? Here you go. Good question. Thanks for asking it. I believe that's the biggest one we sell right there. And in fact, let's take a moment and plug that in, just so you can see that one at work. So what I'll do is, let's see if I've got the right cables for it. Let me go to overhead again and show you this assembly in action here. Let's try to focus a little better. Get that out of the way a bit. So these have a quick connect pair for the switch that is this sort of medium size connector, and that's how easy it is to plug those in. And then these switches are really nice because they actually color the plastic based on positive and negative side of the LED. So if I take the larger size connector, the darker wire is ground, so I can plug that in right there. And this side can go to positive. And now again, since that polarity is keyed to what I just did there, there's no way to plug that in wrong. That'll go in, famous last words, right? That'll go in correctly there and there. And now I've got big, huge, giant button there with a LED built into it. So taking a look at the code that's doing that, you can see here, let me jump back to this view. So I'm importing, the kind of key things I'm importing are my digital I/O, so I can read pins, and Seesaw, so that we can do it on the board. So the little arcade board is a Seesaw board, and I'm importing the digital I/O there as well. Then I'm setting up the I2C bus on this microcontroller, which is actually on the second bus. And then I instantiate each of the boards. I have 2 boards, so I call them Seesaw, I2C, and give the address. On the bottom of the board, you'll see here, we have some little jumper pads that all you need to do is take a small knife and scrape away the connection between 2 of those to change the address. So you can set a whole bunch of different addresses on these to get up to like 32 of these boards or something like that. So here I have them on 0x3A and 0x3B. And in fact, these don't conflict with the slider board, I think. I think these are on pretty distant addresses, so you can mix and match a few of our input types of stemma Seesaw boards. And then I'm setting up the button pins on the board. So these use, these little arcade boards use pins 18, 19, 20, and 2 of the Seesaw chip for digital I/O. And they use pins 1, 2, 3, and 4 for the LED PWM. And so I set those up as buttons, I set those up as outputs for the LEDs, and then my main loop here, you can see it's just dead simple. It just reads through every button constantly, which is why actually you're seeing I have a little bit of a delay on these. You can do this much smarter and faster with things like button masks, but I'm just kind of polling each of them, and there's a little bit of a hit in the Seesaw code for that. And whenever one of those values goes to high, then I set the LED to high as well, or vice versa. So that, if we take a look at the web page here, that is the board. If you refresh your page, you should see that we've got this half off right now, so $4.98. You can look through here for a bunch of info on the boards, as well as links on the side for the different buttons, some of the different buttons you can use, as well as the cables you can use. And then if we scroll down a bit, you'll see Here's a project link for my arcade synth controller, and there's this primary guide. If we click on the primary guide there, that'll take you to a lovely pinout and tell you how to use the board. It does have, if you for some reason want to use soldered connections, you can. You don't have to use the JST Quick Connects if you're trying to make maybe a more compact build. You'll see that there are actually pins broken out on here for the LEDs and for the buttons. And this is one of the newer boards we have, Seesaw boards, that uses the ATtiny 817 microcontroller, which is mentioned here. And this also goes through and tells you about the different addresses that you can set this to and how to pick the jumpers for that. So let's see, I think that does it. Let me jump back over here for a second, and we'll take a look over in our YouTube chat and our Discord. Let me know if you have any questions that we can answer here. Yeah, Susan says I've always wanted a mission control panel. This is great. Look at this lucky kid here with this mission control. This is great for driving this type of a project without going bonkers with all of your connections that you have to make and finding that many pins to use. So yeah, Rich Sad says not sure what to do with them, but maybe an instrument of some sort. This is yeah, really great for doing things like MIDI Fighter, which Lady Ada mentioned, which is usually a 3x3 or 4x4 grid of arcade buttons. All right, well, I think that's going to do it. Let me unplug this right here. So I'm going to disconnect the power to the USB on the microcontroller. And look, everything is plug and play. You can just pop everything off like that. I had a little piece of wire ready to hang this. What way we want to go? How about like that? So set this like so. And that is the product pick of the week. It is the LED arcade button 1x4, which is a Stemma QT-based Seesaw board that requires no soldering to hook up your lighted arcade buttons to your project. And that is the product pick of the week. Thank you, everybody, for stopping by. Don't forget, you can head over to this URL right here if you want to pick up some right now while the discount is in effect. I think we had a few, maybe somewhere over 100 of these ready to go in the store when the show started. So hopefully they're still in stock and you can grab some. Thank you, everybody, for stopping by. For Adafruit Industries, I'm John Park. This has been JP's Product Pick of the Week, and I will see you next time.